acid-base titrations. So oftentimes in chemistry labs we run into acid-base titrations, and we use those to determine concentrations of different solutions. So we're going to do a practice example. So suppose we have a 100 milliliter sample of calcium hydroxide solution, but we don't know what its concentration is. So we're going to have it titrated until it's neutralized with HCl. And we know now that it took 23 milliliters of 1 molar HCl to achieve that neutralization. And now we want to find out what our molarity of calcium hydroxide was. So the first step we want to do is write our balanced equation. So we know we had calcium hydroxide to start with. And to that we added our hydrochloric acid. I'm just going to put an AQ next to both of these because they were both aqueous or in solution. And when we look at this, we're going to do a double replacement reaction essentially. So we're going to end up with calcium chloride and water. Now as you can see, this reaction isn't balanced yet. And in order to balance it, we need to put a 2 subscript in front of our HCl, or 2 coefficient, I guess you should say. So now our next step is we need to determine the number of moles of HCl added. So to do that, we know molarity equals moles divided by volume, and therefore the number of moles is going to equal the molarity times the volume. So in this case, we had 23 milliliters. We're going to express that in liters here since we're dealing with molarity. So we have 0.023 liters times our 1 molar, so 1.00. And that's going to give us 0.023 moles. So now that we know how many moles we have, we can stoichiometrically calculate the moles of calcium hydroxide in the sample. So if we start with our 0.023 moles HCl, we can do our conversion here using our balanced equation to show that it took 2 moles HCl to react with 1 mole calcium hydroxide. So when we do this math, we end up with 0.0115 mole calcium hydroxide. So now we know the number of moles, and we also know the volume of our calcium hydroxide solution. So from that we can calculate our molarity. Once again, we know that molarity is equal to the number of moles per volume, which is expressed in liters usually. And when we do this, we're going to get 0.0115 moles CaOH2, calcium hydroxide, all divided by 0.100 liters, and that's going to give us 0.115 molar calcium hydroxide. So our solution is 0.115 molar. And this is a simple way to go about doing the kind of mathematical process involved with titrations.